everyone, welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Yes guys, this is me once again, Rakesh Sir, live into the session continuing the integral calculus, and we know that we are running on this series daily at 9 p.m. Come on guys, so yes, let's wait, everybody start joining quickly and let us start this next topic, that is the multiple integrals. Right, multiple integrals is what we are going to discuss in today's class, right? Okay, good evening all, keep joining the session. Okay. Chalo. So in case somebody new to my session, this is a brief intro about me. This is your mentor and educator Rakesh. I have secured all India rank 9th in the GATE examination, completed my masters from Indian Institute of Science and have been training the students more than 12 years. My major area of expertise is control system, signal and system, digital electronics, CMT, and in the general area I deal with the maths and aptitude, right? Okay. No problem regarding to revision and all, also we'll bring up separate sessions for you, Divya. Okay. Yes, guys, tomorrow is Sunday, 29th May. So if you want to avail the BYJU'S Exam Prep GATE preparation courses, and if you want financial assistance, you can prove yourself tomorrow, 29th May, and get up to 90% scholarship. For more details, just log into the BYJU'S Exam Prep app. Okay. Guys, a quick reminder. This is once again a quick reminder. This is just tonight coming up in around 1 hour. That is 10:15 p.m. Yes, guys, tonight at 10:15 p.m. just after this session, you can say me and Dheeraj sir are coming live to talk about the complete strategy to crack GATE and get the best rank in GATE 2023 in the first attempt. Yes, it is possible to get the best rank in first attempt. Know how. So, must watch for all dedicated, serious aspirants for GATE examination. And we know that. Okay, we keep on talking about strategy in multiple sessions, but even after making a big plan, big strategy, there is a phase in every student's life where they are highly demotivated, and where they are not able to continue the preparation. They know the strategy, they are clear about the goals, but demotivated, very much down with the energy, not able to move forward. So who can motivate yourself? Self-motivation is the biggest tool. You can always motivate yourself. What is the importance of self-motivation and how to remain self-motivated? This is going to come on Monday. This is going to come on Monday, right? Monday, same time, 10:15 p.m. This will be live on the Monday, 10:15 p.m. Okay, guys. Chalo, let's get moving ahead now. Right. Now, first of all, what are the evaluation methods of double and triple integrals? What are the evaluation methods for the double and triple integrals? Let me give you a briefing about that. Let me just give you a briefing about that, and then let's talk about the question. Okay, suppose, let me just give you an example. Question baad mein solve karte. Let's just take an example. Suppose there is the integral of the form. Suppose there is the integral of the form, maybe 2xy plus y cube dx dy, right? Where x goes from 0 to 1, y goes from 2 to 3. As I told you, all of these integral calculus sessions will be more problem oriented, more point to point oriented, right? So that's why I'm directly starting with the evaluation method. Right, with the evaluation method, and same I've been doing for the previous topics. My idea is within this particular series for integral calculus, I should give you the range of all type of concepts and questions that can be used here. So evaluation methods of double and triple integrals. Now in double integral, you always will integrate with respect to a single variable first. When you integrate with y, x will be constant, or if you are integrating with x, y will be constant, but with respect to which variable you are going to integrate in this particular problem? Or there can be another example. Where I tell you integral y equal to 0 to x, integral x is equal to 1 to 2, right? Any function, it can be any function of x comma y dy dx. See why I'm writing dy dx, I'll make you explain. So in the previous case, you can start integrating with either x or y first. See, you have to just look into the limits. Limits of x 0 to 1, constant. Limit of y 2 say 3, constant. So limits of both x and y are constant, and whenever both the limits are constant numbers, you can integrate with any of the variables. You can start integrating this. Integrate first with respect to what? X or y. Anyone, that is your choice. Here it becomes your choice. You can start integrating with anyone. But look at the case number 2 that I've written in front of you, where y goes from 0 to x. Now, the limit of y is a function of x. The limit of y depends on x, and whenever the limit of y depends on x, you have to integrate first with respect to y. You have to integrate. That is compulsory. You have to integrate first with respect to y. You have to integrate first with respect to y, then with respect to x. So that is what, if both the limits are constant, x a to b, y c to c, then integrate with respect to any variable first. That is your choice, right? That is your choice. If you are integrating with respect to y first, we write a double integral as dy dx. Look at the previous case. I told you the limit of y is a function of x, so you have to integrate with respect to y, right? And whatever variable you are integrating first, accordingly we write down the order, dy dx. Accordingly we write down the order. So the order of integration here is written as dy dx, right? But when both the limits are constant, it could be dy dx or dx dy. You can integrate with any one variable, that is your choice. But if the limit of y are dependent on x, limits of y dependent on x, so you have to integrate first with respect to y. First with respect to y, after that second step integrate with respect to x. Similarly, if limit of x will be dependent on y, then integrate with respect to x first. Integrate with respect to x first. Let us have the better understanding through directly taking up the question. Evaluate integral y 0 to 1, x equal to 0 to 2, 2x square plus xy square dx dy. Right. So guys, I'm able to see basically less attendance today. What is the reason, guys? आज तो कोई reason नहीं होना चाहिए. Right. What do we do? Do we want to block this 9 p.m. Time to learn something, to solve some questions, or it is just a very casual thing? Kabhi kar liya, kabhi nahi kiya. Then then what is the point of this? Fixing up a schedule for you. I will also come sometimes once in a month and teach one concept. Then I will come after 5 months and teach. That way will you be able to learn? You will never be able to utilize that. That will be a waste. So similarly, if students do that, that is totally not acceptable. So let's come to the question. Okay, integral y equal to 0 to 1, x equal to 0 to 2. The integrate with respect to any one variable first. That is your choice. Yes. So come on, keep sharing the session also. So integrate with respect to, हम क्या कर रहे हैं यहाँ पे? Integrate with respect to x. Now I'm just taking it as x. That can be your choice. You can take it with y. So when you integrate with x, right? When you integrate with x, what is the integral? Now, as I told you, if you are integrating with x, y has to be constant, right? 2x square. X square integral is x cube by 3 plus x square. X integral is x square by 2. Y square is constant right now. And then because you have integrated with x, put down the limit of x, that is given from 0 to 2, and then you have y. Then you will integrate with y under the limit 0 to 1. Okay? Under the limit 0 to 1. Okay, Jyoti. Chalo. Now put down first the limit of x. The limit of x will become 2 into x cube, that is 8. 2 8 16, 16 by 3 plus upper limit 2 square 4, 4 by 2, that is 2y square. Now what should be lower limit? When you put x 0, so this is also 0, second term is also 0, lower limit is entirely 0. So now you are left with integral of a function of y with respect to y. Limit of y 0 to 1, complete the integration. This becomes 16 by 3. 16 by 3 integration is 16 by 3y plus 2y square. Y square integral is simply y cube by 3. Lower limit 0, upper limit 1. Calculate the final answer. That should be 16 by 3 plus 2 by 3 upper limit, lower limit is just 0, 0. So 18 by 3, final answer is equal to 6. Correct, Bhavya. Correct, Bhavya. Good evening, Tushar. Right. So correct answer is equal to the 6. Even if you integrate with y first, you are 110% going to get the answer. That is 6. No issues in that. Now, a simple, just as a reference, very simple gate, 1 mark question. The integral 1 to a, 1 to b dx dy upon xy. The limit of x and the limit of y are both constant, 1 to a, 1 to b. Whenever you have both constant limits, you can integrate with respect to any one variable first. Right, you can integrate with respect to any one variable. 1 to a, 1 to b dx dy upon xy. Suppose I integrate with x first once again. Right, so this becomes, what is the integral of 1 upon x? 1 upon x, log x. Right, and when you are integrating with x, y is constant. Y in the denominator is constant. What is the limit of x? ये ले लिया 1 to b. Right, ये ले लिया मैंने 1 to b. dx पहले लिखा है तो ये लिमिट मैंने x का ले लिया. And then you have dy. Right, where the limit of y is 1 to a. Now guys, what is happening? Upper limit of x, log b. Lower limit of x, log 1. That is totally constant. Log b minus log 1 is constant. Right, and that is outside the integral. You have now 1 upon y dy. Limit of y 1 to a. Right, so this becomes log b. Log 1 is equal to the 0. 1 upon y integral is log y. Lower limit 1, upper limit a. Once again, that becomes upper limit minus lower limit. That is log a minus log 1. The value of log 1 is 0. And the final answer is log a multiplied by the log b. Log a multiplied by the log b. Option number D should be the correct answer. Right. No, Bhavya, not in general. Okay, option number D. Now, an important point to learn here is, the function is 1 upon xy. What is the function given here? That is 1 upon xy. That can be written as 1 upon x into 1 upon y. So, actually what happened? You just integrated function of x and y is separate. Y is separate, totally separate. And because it is totally separate, once you put the limit of x, after putting the limit of x, it is outside the integral, it is constant, and then you are integrating the function of y. So when we know that x and y can be separated, why not integrate x and y at the same time and keep the limit separately? This is known as variable separable. I will explain you a little more easily now. Right? F of x comma y is 1 by xy, 1 upon x into 1 upon y. That is some function of x into some other function of y. Right? Whenever वेरिएबल सेपरेबल थियरी ये बोलती है, दिस इज नोन एज द वेरिएबल सेपरेबल, राइट, डबल इंटीग्रल एफ ऑफ एक्स कॉमा वाई dx dy for x equal to a to b, y equal to c to d, right, can be written as, if f of x comma y can be separated, so you just have to solve it in the single step. Integral f1x dx, right, with limits of x a to b, multiplied by integral f2y dy. Integral f2y dy, where the limit of y is c to d. You have to just integrate separately. Rather than first with x, then with y, integrate with x and y in the single step, but both separately. A variable separable. That is variable separable. Right. Suppose, for example, I don't have any extra slide here. Oh, that cannot come here right now. No, that is not good. Chalo. Let's understand here. One more example. Okay. One more example. What is that one more example? But मैं यहाँ लिखूंगा ना, so it will not come in your final PDF. If I write here, it will not come in your final PDF. Just wait for a second. So just as an example, let me explain you this thing. Suppose you have a question. Integral x equal to 0 se 2, y is equal to 1 se 3, x square y dx dy. So x square y, it is clearly separable. X square is separate, y is separate, right? So what you can do to calculate this, you can just integrate x square with dx. You can just integrate y with dy. You don't have to take a two-step process. You don't have to take a two-step process. The answer is x cube by 3. Now put down the limit of x 0 se 2. Y ka integral y square by 2. Put down the limit of y, that is 1, 2, 3. Right, so this becomes 2 cube, that is 8. 8 by 3 multiplied by 3 square, that is 9, minus 1 square divided by 2. Right, this becomes 8 by 2, 4, and answer is 32 by 3. Answer is 32 by 3. So you can solve both the integrals, separate them and multiply the result. Okay. Chalo. Now, a gate 2 mark question. What is the value of the integral 0 se 2, 0 se x, e power x plus y dy dx? Right. Area under curve session is on Monday, Arvind. Area under curve session is on the Monday. Right. Area and volumes. Volumes will be on Tuesday. Everything regarding to integral calculus that is there for the gate that I am taking. So Monday will be area. Sunday there will not be any integral calculus class. Sunday 9 p.m. you can take a deep breath. But again Monday 9 p.m. area. Tuesday 9 p.m. volumes. So both the sessions are already planned. Okay. Integral 0 se 2, integral 0 se x, e power x plus y. Now see very clearly. Integral 0 se 2, integral 0 to x, e raised to the power x plus y, e power x plus y hai na, e plus x plus y dy dx. See, y dy dx is given. You can directly feel that the limit of y, right? The limit of y. What is the limit of y here? The limit of y is 0 to x. Depends on x. So now you are not left with a choice. The limit of y depends on x, so you are not left with a choice. You have to integrate. You have to integrate first with respect to y. Limit of y dependent hai, so you have to integrate first with respect to y. So the integral now becomes acha, e power x plus y, right, can be separated also, right? This is e power x, e power y. You cannot apply a variable separable because constant limit nahi hai. I'm just separating the function. E power x, e power y, dy dx. Right, so e power y, you have to integrate first with respect to y. Integral of e power y is e power y. Lower limit 0, upper limit is x. Y limit is 0 to x. And then you will integrate with x. The limit of x is equal to 0 se 2. Right, now this becomes, first put down the limit of y. E raised to the, and e power x to height, sorry, I forgot that. So e power x is there, then e power x minus e power 0, that will be 1 dx. Right. This is e power 2x. What is the integral of e power 2x? E power 2x by 2 minus e power x. The limit of e power x is e power x. Lower limit hua 0, upper limit hua 2, and then this becomes e raised to the power 4. ठीक है, यहाँ पे लिख लेते हैं इसको. Okay, what is the answer? Upper limit e raised to the power 4, e raised to the power 4 divided by 2 minus e raised to the power 2 minus the lower limit. Lower limit x की जगह 0, so just 1 by 2 minus 1. So this is e power 4 by 2 minus e square. Minus half becomes the plus half, और अगर 2 को हम common ले लें तो e power 4 minus 2e square plus 1. This is a square minus 2ab plus b square. 1 I can be written as 1 square. So this is e square minus 1 whole square whole divided by 2. Okay. E square minus 1 whole square divided by 2. E square minus 1 whole square divided by 2. Option number B is ready for you. Option number B, it was an MCQ question and 2 marks. Simple calculation, but just you have to identify that the limit of y depends on x, so you have to integrate with y first. You have to integrate with y first. You have to integrate with y first. Moving ahead to the next problem. Now, let this be a homework for you because it is a similar integral calculation. Let this be just a homework for you. देखो यहाँ पे क्या दिख रहा है आपको? What is the limit of x? It is 0 to y. The limit of x this time depends on y. So only thing is, rest all integration formula process will be same. Only thing is you have to integrate with respect to x first. Limit of x depends on y. You have to integrate with respect to the x first. Okay. So you can just complete this activity as a homework. Going forward, what is the value of the integral over the region R, x square y square upon x square plus y square dx dy, where R is the region bounded by x square plus y square equal to 1 with y greater than equal to 0. Sir, what is the region R? First of all, understand this. What is the region R? X square plus y square equal to 1 with y greater than equal to 0. Everybody should know that x square plus y square equal to 1 is? Everybody should know what is x square plus y square equal to 1. What is x square plus y square equal to 1? So we all must be knowing that x square plus y square equal to 1 is a circle. Having the center at 0, 0 and radius equal to 1. R square is 1, R equal to 1. A circle of unit radius. But I want y greater than equal to 0. I want y, this is the y axis, vertical axis. I want only positive value of y. I don't want negative value of y. That means I will be considering half of this circle, not the below portion. It's a semicircle actually. With this condition included, it becomes a semicircle. It becomes what? It becomes a semicircle. Right, sir? So it becomes a semicircle of radius 1. Now, x square plus y square, R is the region bounded by this line. R is the total region, not lying on this, bounded by this. So what is the overall portion which is bounded by this? This entire portion. For positive y, what is the region which is covered under this? This is the region R. This shaded region, this is known as the region R. Okay, sir. This shaded region is known as the region R. Acha. Okay. Now, how to define the limits? First of all, you are able to see that the region has circular symmetry. The type of region that is given is having circular symmetry, and let me tell you guys, whenever you have circular symmetry, you should solve the question by polar coordinates. Whenever you have the circular symmetry, you should solve the question by polar coordinates. Let me give you a quick recall, guys. What is polar coordinates? Different type of coordinates when you study. Okay, let me give you a quick review, quick recall. What are polar coordinates? Right. Polar coordinates, in the polar coordinates, you can represent x is equal to r cos theta, y is equal to r sin theta, and dx dy is r dr d theta. R dr d theta. Acha. Now, what is the range of R and all those things? Okay, so I can cover up any points within this circle. This circle or this semicircle has the radius equal to 1. This circle or the semicircle has the radius equal to 1. So what I will do is, sir, I will take any specific circle that has some radius R. I will take a circle having some particular radius R, right? And if I take any point on that circle, if I take any point on this red circle, let us say that angle subtended by that point with respect to x-axis is theta. Okay. So there are so many points within this circle. I consider one more circular arc. I consider one more semicircular arc having some radius r and having some theta with respect to x-axis. Now listen very carefully, very carefully, very carefully. If you want to travel all the points of this red circle, I hope everybody is able to concentrate only on the red circle. If you want to travel all the points of this red circle that I have drawn, you will have to vary what? You will have to vary theta. You will have to vary theta. From where to where? Sir, the first point lies... Oh, I'm sorry. Sir, where to where? The first point lies on the x-axis. And when the point lies on the x-axis, theta is 0. Sir, start increasing theta. Theta starts increasing from 0, 0, 0. It becomes 90 and it goes into the second quadrant and it becomes the opposite line. 180 degree, right? 180 degree. How much is this angle, guys? This is known as 180 degree, na? This is known as 180 degree. So, to cover all the points of this red line, to cover up all the points of this red line, I will first change the theta from 0 to 180 degree. Okay. Then, this covers only the points of one red line, but I have to cover all the points above y-axis, but under this circle. Above the y-axis, under the circle. So, what I can do is, I can create several such red circles, right? I can create several such red circles. I can create several such red circles. That means I can take circles of different radius, right? Maybe less radius, maybe little more radius, or etc. Right? So I can consider different circles where the minimum radius of the circle can be 0, and then keep on enlarging the circle up to the radius equal to 1. Up to what? Up to the radius equal to 1. Up to the radius equal to 1. Right? So that means, looking into this picture, what is the range of R I can take is 0 to 1. Right? And what is the range of theta? Is 0 up to pi. 180 degree means pi. 180 degree means pi. Okay, now let us come to the question. What is the question? Double integral x square y square. So whenever the region has circular symmetry, then only you will think about polar, not everywhere. Otherwise, it can complicate the problem. Okay, x square y square dx dy divided by x square plus y square over the region R. First of all, substitution I told you, x is r cos theta, so this is r square cos square theta. Then y square, that is r square sin square theta, divided by x square plus y square, r square cos square theta plus r square sin square theta. dx dy is r dr d theta. पहले simplify करेंगे इसको. So this integral is now the integral of the form. Everybody see, denominator r square is common. Cos square theta plus sin square theta will be 1. R square common, cancel with one of the r square. So what is there in the numerator? R square multiplied by r, total r cube. Total r cube. Then you have cos square theta and sin square theta also. Right? Then you have dr d theta. Sir, what is the limit? What is the limit? Limit already I explained you. R goes from 0 to 1. Theta goes from 0 to pi. Theta goes from 0 to pi. Sir, limits are constant. R is 0, 7, theta 0, so pi. Limits are constant and the functions are also separable. R is separate, theta function is separate. So let us apply. Let us apply variable separable case as I explained you. Let us apply what? Let us apply the variable separable case, guys. Let us apply the variable separable case. Separate the variable. So this is going to become r cube. Okay, पहले इसको मैं यहाँ पे show कर देता हूँ. This has to be integrated as integral r cube dr and integral of cos square theta sin square theta d theta. Okay, cos square theta sin square theta d theta. That is how it has to be integrated. Okay, so now it becomes r cube. R cube integral is r power 4 by 4. Lower limit has 0, upper limit 1. Integral. Now what is the range of theta? Theta is 0 se pi and r was 0 to 1. Acha. I'm just giving you hints to solve this integral. I've already explained you in the past 2 classes regarding to it, either through the beta function or either through the Wallis integral formula. Limit is 0 se pi. right? But once you check f pi minus theta, that will come to be f theta, right? So limit 0 se 2a will become twice integral 0 to a. 0 to a means 0 se pi by 2, and 0 se pi by 2 means it is the Wallis formula now. 2 into 2 minus 1 double factorial, 1 double factorial 1, again 1 double factorial 1, divided by 2 plus 2, 4 double factorial. What is 4 double factorial? 4 into 2, right? Whole multiplied by, both the powers are even, whole multiplied by pi by 2. Whole multiplied by pi by 2. So final answer is, देखो कितना हुआ? This is 1 by 4, right? तो ये 2 यहाँ से cancel हुआ, 4 4 16, 2 pi by 32. This particular integration I have calculated orally. Why? Because I have the habit of Wallis theorem. If you also have the habit of Wallis theorem, you can solve this particular integration, which may be complicated to solve directly. Complicated means time taking, little time taken. I have solved it within 10-15 seconds in the brain using the double factorial concept, using the Wallis integral concept. Using the double factorial and Wallis integral concept, right? That ways you can also do it quickly. That ways you can also do it quickly, right? Okay, guys. Now let's move ahead to a new interesting case. Sure. Okay. I'm just arranging some slides. अब देखना. Consider the shaded triangular region. Consider the shaded triangular region shown in the figure. This is the region R. Okay, shaded means actually it is entirely white. मैं ये भी लिख देता हूँ. This is the region R. This entire what is double integral? What is double integral xy dx dy? Double integral xy dx dy. Now this does not have any circular symmetry. This does not have any circular symmetry. Okay. So don't even think about polar. But sir, limits are not given. Usually in the double integral questions, the limits were given. A region is given. Can you find out the limits from the region? Can you find out the limits from the region directly? Yes sir, why not? Can you find out the limits from the region? बिल्कुल try करते हैं, ये देखिए आपके सामने. Okay. To find out the limits of a region, what you can do is start taking, you need to travel all the points within this region. Start taking a vertical strip, a vertical thin strip. By thin strip I mean a strip which is having a very small width, nearly tending to 0. Okay, take a vertical strip. So I'm breaking the region first into a vertical strip, and then I will be sliding the vertical strip from left to right. Then I will be sliding this vertical strip from the left to the right. I will be sliding the vertical strip from the left to the right. Okay. I will be sliding the vertical strip from the left to the right. ये कर लेंगे हम लोग, ठीक है? We'll be sliding the vertical strip from the left to the right. All okay? Okay. Now, what is the limit of this vertical strip? I want to find the limit of the entire region. So what is the limit of this vertical strip? Okay, this is resting on the x-axis, y equal to 0. Vertical strip means you will tell the value of y. Vertical coordinate is the y coordinate, right? What is this y? So what is the equation of line? What is the equation of this line? Now it has the x-intercept equal to 2. It has the y-intercept equal to 1. So I use the intercept form. X by a plus y by b equal to 1. Right. So what is the value of y? 1 minus x by 2. So what is this y? Y is equal to 1 minus x by 2. Now I know the vertical coordinates of this strip, but I don't want the points only on the strip. I want the points of the entire region. So what I will do now, everybody see what I will do now. I will be sliding this strip from left to right. I will be sliding this strip from the left to the right. Okay. Now when you slide it from left to right, what is the limit of x? Limit of x 0 say 2. You will slide along the x-axis from x equal to 0 up to the x equal to 2. X equal to 0 to x equal to 2. So what is the integral calculation now? The integration can be written as क्या था? xy dx dy, limit of y is 0 to 1 minus x by 2, and the limit of x will be 0 say 2. The limit of y depends on x. The limit of y depends on x. So first you will integrate with y. The limit of y depends on x. So first you will integrate with y, and that is why I just changed it to dy dx. Now just complete the question. First integrate with y. Okay, sir. Let us do the integral of y. Y dy is y square by 2. Lower limit 0. Upper limit 1 minus x by 2. Right. Integral dx is left. X ka limit 0 say 2 is left. Put down the limit of y first of all. So this becomes integral x. Upper limit of y, 1 by 2 को outside कर दिया मैंने, 1 by 2 is outside, then you have 1 minus x by 2 whole square. Lower limit of y is 0, right? So this is 1 by 2 integral x into 1 is x. Then x by 2 का square is x square by 4 into x किया, so that is x cube by 4, right? A square plus b square minus 2ab, so minus 2ab will become minus x, and that is into x, so minus x squared dx. Right. Now integrate with respect to x. 1 by 2 is outside. X integral is x square by 2. Then you have x power 4 divided by 4. 4 4s are 16. Minus x cube is divided by 3. Limit जाएगा x का 0 से लेकर 2. Substitute the limits of x. Just substitute the limits of x. So what is the limit of x now becoming? Right. X square, that is 2 square by 2, that is 2, right, plus 2 power 4 by 16, that is 1 again, minus 8 by 3, lower limit is 0 0 0. Okay, so 2 plus 7 3, 3 3s are 9, 9 minus 8 1, 1 by 3 into 1 by 2. Final answer, sir, is 1 by 6. Final answer is 1 by 6. Yes, correct answer is option number A. Final answer is 1 by 6. You have it in the option number A. You have that in the option number A. Okay. The correct answer is 1 by 6. So what I have taken? I have first taken here a vertical strip of negligible width. Negligible width means very thin. Negligible width means very thin. Very thin. Okay. Acha, sir. Why you only take vertical strip? Can't we take horizontal strip? Yes, sir, you can. Can't you take horizontal strip? Yes, you can. Yes, you can. By taking this horizontal strip, let us see how the limits are changed. The horizontal strip, that means I am taking the strip along the x-axis. I am taking the strip along the x-axis, right? So first the strip starts from y-axis. X is 0. And what is this? What is the equation of line? We already know. We already know the equation of line. X by 2 plus y equal to 1. Right? So what is the value of x? X is equal to twice 1 minus y. Twice 1 minus y. Then, yeah, that is what Jyoti I am explaining, na? What horizontal strip. Then you will slide this horizontal strip. Then you will slide the horizontal strip from bottom to top along the y-axis. And when you slide it along the y-axis, the limit of y will be 0 to 1. The limit of y will be 0 to 1. So, what is the integration written as then? The integral will be now written as integral x is equal to 0 say twice of 1 minus y. Integral y is equal to 0 to 1. xy. Now the limit of x depends on y, sir. The limit of x depends on y. So first you will integrate with x. The limit of x depends on y. So 100% first you will integrate with x, and then only you will integrate with y. First you integrate with x, then you integrate with y. अच्छा गाइस, सॉल्व आप कर सकते हैं, सॉल्व and 100% you get the same answer. 100% you get the same answer because you have the same function and you are integrating along the same region. Only way is considering the points of the region first vertically or first horizontally. Only difference is geometry, but you cover up the same region for the same function. Answer is 100% same. Now, in the first case, I have written xy dy dx. Because in the first case I had a vertical strip, so limit of y came up first of all. Y is 0 to 1 minus x by 2 and then x is equal to 0 to 2. In the second case, I have the same function xy, but the order of integral is dx dy. First x and then y, because the limit of x were dependent on y. And then I have written y is equal to 0 to 1, the previous form. And both will give the same answer. Both will be the same answer, and this is nothing but known as the concept of changing the order of integration. Changing the order of integration. This is what is known as changing the order of integration. Right? Changing the order of integration. Changing the order of integration. Okay. Okay. Chalo. There may be any function. Just a second. Change the order of integration, guys. Change the order of integration. Integral f of xy dy dx. First I am integrating with y. Y equal to root x to 1. Y equal to root x to 1. X is equal to 0 to 1. X is equal to 0 to 1. Now, if you have understood the previous example, so let me allow you to solve this particular question as a homework. Okay, let me allow you to solve this question as a homework. Let me see whether you have understood and whether you are able to implement it. See, in the previous question, directly the region and diagram was given. Here, I have given you the integral from here. From looking into the limit, you have to draw the region. The limit of y is a function of x. Y depends on x. Matlab vertical strip is given. So first you have to draw the region according to the limit and convert the vertical strip into horizontal. It is only changing the strip. You will get the answer. You will be getting the answer. It's a homework. Change the order of integration. So this is one homework for today. And guys, yeah, even when you are required to solve the triple integration, the process is same. When you're required to solve triple integral, the process remains to be same, right? Whatever limit is dependent, first you have to integrate with that particular function. First you have to integrate with that particular variable, right? So since I have another session and I need to get some PPT prepared for it, so I'll be stopping this session for today, but I'll just give you this hint. Suppose this is triple integral, right? Limit of z depends on x. First integrate with respect to z. Limit of z depends on x. Process will be same, calculation will be same, right? First integrate with respect to z. Now limit of x and y are both same. Then with respect to x or y. ये आपका choice हो जाएगा. This will be your choice. So actually dz should come first, right? Actually, right, 2x plus y minus 2z. DZ. First DZ. Actual order is, see, question they can write randomly, but you have to identify the actual order, the DZ, right? Then whether with X or Y, your choice. Okay, so let us take Y. So Y ho gaya 0 se 2. Let me write dy, and then let us complete dx. X is equal to 0 to 1. Or you can swap X and Y. That is your call, right? So this is also a homework for you. Hint I have given. This homework, this will give a numerical answer, and this numerical answer you can comment in the comment box. This will be a numerical answer, and this you will comment in the comment box. This you will comment in the comment box. Previous one is a change of order of integration. So that is an expression you can't comment, but at least you can comment the answer of triple integral. Right. So, 10:15, around 20-25 minutes, maybe later, I have another session on the same channel. So stay subscribed and stay updated. That is an important strategy session, and that's why I need to stop it little early today. I have some, presentation also to complete. So guys, the password for today's PDF. Guys, yesterday I shared you the yesterday and day before yesterday. Both the PDFs I shared you yesterday in the Telegram. So you can once again find the today's PDF in the Telegram channel, same Telegram channel, and the password will be multiple. Simple, random password. Password will be multiple. So note the password multiple and you will get the PDF in the Telegram with the password which will be multiple. Okay. So guys, coming live right now. In 25 minutes. Coming live with Dheeraj Sir. Dheeraj Sir is also there in the office. He's also winding up his another class. Right, and we'll be coming live together in 25 minutes to tell you GATE 23 in single attempt. What should be the perfect strategy, and let's do it. If you are putting the hard work, this particular attempt should be a successful attempt, right? So it's a generic session, going to be a little smaller one only we expect. So do join us and learn some important aspects, what mistakes you should avoid and what are the correct steps that you should take if you're a GATE aspirant. This is going to happen on Monday, right? This is definitely going to occur on Monday, right? So sometimes you know how important self-motivation is and how to remain motivated throughout the GATE preparation. I will tell you separately on Monday 10:15. This is other than strategy. Sometimes we know the strategy, sometimes we know what to do, but we are not able to do. We are demotivated. We are not able to overcome some of our weaknesses. So regarding to that, let's have a little chit chat. It's just a discussion session, chit chat, how to remain self-motivated for the competitive exam. Thank you guys. So do not forget to subscribe the channel so that you get all such general session, you get maths classes, you get all technical classes are also going on, right? Okay, so for technical classes for all branches are going on. So just keep subscribed and let's connect in another 25 minutes. Bye bye. Thank you. Stay safe and take care.